Alright, seems to be live. I'm continuing the work on this PCB, and right now I'm routing the power connections for the motors, which means that they have to be thick enough to support the currents that are going to be flowing through the circuit. And to do that, I'm using multiple copper layers. I'm trying to make the most out of the PCB structure to make sure that these connections can lead enough current without heating up. So we have I've created slightly modified footprints for the transistors, which means that there are some connections here that actually are part of the footprint. For example, I've created a connection here and all the vias here. They're all part of the footprint, which makes it easier to connect everything on the PCB using just copper fills. And I have this VMOT connection here, which goes to the capacitor, and there's really no place for me to place this capacitor other than on this position here, because I have a smaller capacitor here and I have the transistor there. It's actually easier to see if I open this in 3D. So the high currents will flow from the VMOT line, which goes on the inside of underneath this transistors, and then it will come in on through the PCB, through the vias, will come in on the VMOT line here, VMOT pad on the transistors, and then it will be switched to the motor lead here, and then it will go through the motor and come back here and go through this lead and through this transistor down to the ground. And this is the ground connection on the transistor. It's this little pad here. So all of these, this whole path has to be as low impedance as possible so that it doesn't get hot. I've created a custom footprint for the transistor, which makes it, which looks kind of like this, and routes the ground path through the vias to the inner layer, which is the ground. I have the second layer from the top is my ground layer. But I also need to make sure that connections to the capacitor, for example, which will provide extra current when the motor is switching, that they are thick enough as well. So just to minimize the resistance. It's not so much the thickness of the trace that determines how hot it gets. It's the resistance of the trace. So by adding vias, I can actually lower the resistance of the whole assembly when I have multiple layers with copper and connect them by through the vias. I lower the resistance of the whole thing, so it doesn't get as hot if the resistance is low enough. It is impossible to know what the resistance will be when adding several vias and having irregular shapes. So the only thing we can go after is kind of the non-layered trace. We can use the KiCad calculator to calculate the necessary width of the trace, considering only the thickness of the copper. But the moment I start adding vias and connecting multiple layers, it gets to a whole different story, because now we have lots of low impedance paths between the layers, and we also have much higher surface area, and we also have the ground plane, which leads the heat away from this area. So it's kind of you have to kind of like use your common sense and just make sure that the connections are as thick as the PCB would allow, sort of as thick as the PCB structure and the layout would allow. So that's what I'm doing here. I will go back to this. Let's see, to this place here, and I'm going to create an area here that covers this VMOT pin, or this pin on the capacitor, and the VMOT connection on the transistor. And because KiCad doesn't allow intersection of copper zones, I have to create cutouts, and I I have to make the zone exact shape so that no zone intersects any other zone. This will be the top layer, and it will be the VMOT connection. And one of the most annoying thing with copying and pasting copper fills is that they do not, the copied and pasted copper fill doesn't come with the same net, so it gets with the net unassigned. So you have to edit it, and you have to set the net name, like in this case it's the VMOT. Right, I'm gonna make it a bit bigger here, so I'll go here and I'll just drag the whole, make it one big fill. And it doesn't matter if there are traces underneath, because everything gets combined by KiCad into the final the final shape of the copper. Let's copy this one now. So I'll copy, and one of the things that makes it easier to edit copper fills is if I hide the footprints at the top, then I don't get the footprint selected, so I can just select the copper fills. So copy this one. No, damn it. Let's see. Copy this one, paste, and let's see. So right. And this copper fill now is not connected to the VMOT, so I have to manually connect it, which I think is pretty much a bug in KiCad. We have right. We have the. I think we have both copper fills on the front of the PCB. So I will create the same copper fill on the back, and it seems that the copper fills somehow got merged together. So let's do this on the front, and it's gonna have VMOT, and now we have let's see, that is the track, so zone fill VMOT on front and back, and I could also, let's see, and I could also create the same fill on my inner layer, second inner layer. I try not to disturb the ground too much. The ground is going to be one continuous copper fill, because that is important, because currents will flow through the currents always flow to the ground. So if you have a discontinuous ground plane, then currents will flow around components, and they'll take sort of different routes to the ground. And it's actually the same thing with mounting holes. Let's just make this VMOT, and let's have a look at the mounting holes. So the reason I never connect the mounting holes to the ground on the PCB is because I don't want current to flow through the internal the plated side of this hole and to the screw, and then to the frame. And I don't know where it ends up. It could end up like if there are several boards that are mounted on the same frame, like it could actually flow to another board first, and then it could go through that board and back to the battery. So any power that goes into this board is going to have to come back somehow. So if the mounting holes are connected to ground, what will happen is that this high current that comes through the motor and back to the battery can actually flow through other boards on the same frame. So I think it's really important not to connect mounting holes to ground. And my rule of thumb here is that anything that can connect to something else that can also connect to the same battery as this board shouldn't be connected to the same ground on this PCB. So for example, the USB connection is a different thing. It could be connected to the same battery, but it will never be connected to something that will be powered from the USB and that will draw high currents. So we could assume that the USB connection is pretty much only used for something that is outside of this assembly, that doesn't connect to the same battery. And then it's okay to ground the shield of the chassis of the USB connector. For example, with a Ethernet connector here, if I have this Ethernet cable connected to something on the same board, or this EtherCAT, which it will be, so this will always go to the same to something else that is on the same assembly. Then the currents that are switched through the motor can actually flow then through this Ethernet shield and go to another board, and then through this cable and through the other board, and then to the ground on somewhere else. And that's pretty obvious that will create a lot of noise, and it will create a lot of unnecessary interference. So the EtherCAT connectors, I'll make sure that they are not connected to the chassis. The shielding of the connector is not connected to the same ground, but is connected to chassis ground. And I could actually connect the chassis ground around the PCB. That's not really strictly necessary, but I could do that. Let's see how we can continue with this layout here. So for the high power traces, I'm mainly using copper fills. The ground connection here is going to go to the current sense resistor, and it could actually benefit from putting the resistor as close as possible to the pins. Let's place it a bit more precisely like that, so that this connection is as minimal resistance as possible, and we can connect this then with the copper fill, which will have actually the net name of this. This would be C135 pad 1. Let's see. So we got C135 pad 1. In this case, I could actually just use a thick wire. Let's add a new via size of 2 millimeters and 4 millimeters. No, track width. I mean, so track width of 2 millimeters. So. Did I just get a dialog somewhere? No. There we go. Okay. So this, yeah, maybe, I think 2 will be actually too thick. Yeah. 1 is enough here. And I think we could also place a copper fill on the back, which will cover this area. So let's see, C135 pad 1. So okay, I'm gonna have to adjust this copper fill. and create corner, and then I'll just move it here. Right, and the reason I placed it like that is because I want to add some bias there. And especially because this is the current sense resistor, it has the potential to get hot. So it's important to use the PCB structure as much as possible to make sure that as much as possible of the heat can be led away from the resistor. This will go. Let's see. And one way to achieve this is to have this copper heatsink underneath and on the top here. Let's see. I'm going to hide the footprints. I'll just copy this this zone and place the same copy on the front layer. And it's really annoying that I have to select the net again. All right. And I'll use bias that are 0.5 for this. Let's change the grid to 0.5. Would this be too... No, this is not too much. This is good. Okay. And also, with regards to to vias that are on the pads, like for example, I could place a via on the pad to connect this pad to ground. The problem with that is that it requires a special technique for plugged vias in order to work properly. If you don't order that from the manufacturer of the PCBs, then what you get is actually, like in most cases, it may actually work fine, but it's not guaranteed, and you can actually have a hole that sucks the solder paste into the via, and you don't basically get a bad joint on the component. So when I don't use the via on pad as much anymore, because I think that for the most for most common designs, it's not really necessary. I could just lead the ground out a little bit and then place a via there. Like even placing it pretty close to the pad, like I did here, but without the hole actually touching the exposed surface. We can hide the copper, and we can see this is the exposed surface that is without the solder mask. So the holes are filled with solder mask in this case. They will be pretty much closed using solder mask, but that's not guaranteed either. So let's see. I'll go back to do the same thing here. This would be C115. That's fine. C115. Pad 1. And then paste another one. And this will go to the bottom layer. And also C115 pad 1. All right. So I could have made this part of the footprint as well. That would have been a bit easier, actually. But for now, I'll just do it like this. Now, another thing that I want to check here is the clearance on the inner layers. So we have distance, spacing in inner layers, 6 mil for trace spacing. So we could actually, well, let's see, I think there was a different one for the copper fills. Let's see. So between 0.2 and 0.34, I think would be reasonable for this. Let's see what clearance we have. We have way too much clearance. Make this 35, 0.35. And anti-pad clearance 0.35 as well. Spoke width can be kept the way it is right now. And we get slightly better fill of the ground here. And actually, I'll get rid of this. Okay. Like that. Now I'll only use the inner layers there. That's good. Okay. Could use a little bit more area here coming out of this ground. Let's see. I'm just thinking what would be the best way to do this. whether I should just create a fill over here that just connects to ground. I think that would be better. I think that would be the best thing to do here. Let's see. So we've got fills there. So I have to avoid this. Maybe actually I don't have to. Yeah, I don't have to. So the advantage of having the fills on like equivalent of the fills, but expressed as pads on a component, is that I don't have to cut around it. I can just have a copper fill that has a straight line here. This would be, let's see. I think I could do. I'll keep one that just ends here, and then have a different one for the other drive. And then this will just fill the whole area here. So because this fill will be cut into smaller segments by the tracks, we're going to have to place stitching vias around it. But I'll place that a bit later, just like I did here. So this should be fine. And also, right, so I want to change the connection style. Let's see. We can delete this corner. And the connection style will be thermal relief. That's better. Except it's not really better for this one. And that's quite annoying, but I think the best solution for this is to edit this footprint of the resistor. Let's see. This is in custom anyway, so I'm gonna just I'm gonna copy the pads. So what I do is I copy the pads, but then I change the style of the pad after I've copied it to not have paste and mask. So I have a second pad that doesn't have paste and mask, which will just represent copper. Let's see. So I'm not really sure right now about the size. So I'm gonna just make it 5.5. I'm gonna measure the size. So I want to go all the way, like, let me just add another via there, just so I know the distance. Through hole and hole size 0. Let's make this 0.3. It will have to be, or actually, maybe 0.5, and then 0.7 here. So circular and 0.7. That's too big. I think that's too big. Yeah, that's too big. Let's go with the standard one, 0.2 and 0.5. Like that. Okay. So if I place that there, then I can just make this pad around maybe 650. $660. That's better. And I'll copy this one and also create the same type of pad on the back. Do we actually need this? Actually, no. I'm not going to do this for this footprint. I'll just add the bias. So 1, and let's try 0.5. Will be more symmetric, I think, perhaps like this. And then 0.2. No, it's not symmetric. How far is the distance there? If I press space, I can measure the distance. It's 275. Yeah, that doesn't really divide into the common grid sizes. Maybe I just move this. Yeah. And then place the other one at like 1.3. 1.3. Okay. This is totally useless to do it like this. Two. Okay, save the footprint and let's see. Oh, right, and also, yeah, let's change the type here. So if I open this in the footprint editor, actually, what I could have done that would simplify everything. would be to just, let's see. Oh, I didn't have any shit. Let's see. So this would be 5.1. Oh, damn it. Right. Let's update this. So what I could have actually done was to just select the pad there and choose connections to the, let's see, yeah, connection to copper zones solid, and that would have solved the whole issue. I think this is actually much better. Yeah. I'll change this back. No need to complicate things too much. And refill, and then we have the connection that is just completely solid. Now this zone here, right, I need to create a cutout for this zone because it's not going to work like that. It has to, I'm going to create a corner here. Let's see. It's going to complain that these two zones are intersecting. Right. So it would have been a bit of a benefit still to have a pad that goes here. But anyway, I'll just hide the footprints and select this zone and create corner. Then I'll drag it around this. So actually, why not just do like this? So we get the maximum zone size. Okay, and now this zone will need to have another corner here. Like that. And create corner like that. And then basically the same thing for the second one here. Create corner. Oh, damn it. No. And undo. Right, yeah, that worked. Create corner. And then let's move this one here, this one there. Create corner. And the last corner. Okay. And just maximize the size of this area. Okay. I'll just make the distance a bit bigger there. And fill. And now we should have these fills done. All right. So the problem here is that the ground is not connected to the resistor. So this kind of needs this needs to be moved a little bit. We refill and then we get the grounds connected. Perfect. And it's actually the same thing here. Okay. And I think for my taste this spacing is too large, so I'm going to change it to the specified minimum spacing of 0.35 maybe. So we have spacing trace to copper, 8 mil, 0.2 minimum, but that's really small. It's not really necessary to go that close. If the spacing is too small, it could in some cases create artifacts where things can get shorted. But if the manufacturer says that it's okay with 0.2, then that would be definitely okay. See, so I select this copper zone, and right, I already have 0.35 there actually. 0. Yeah, could leave it at 0.35. All right. So I've pretty much been using copper fills so far. I could connect the resistors here. This would be the control signal. So I'll use a slightly thicker trace for that because it carries current. 0.25 millimeters is enough according to the PCB calculator. So this will just go here and here, and just connect these two, and then this goes to the, let's see, do I want to start routing this? Can I maybe do something, connect these two? Is there anything I forgot here? Right, yeah, the VMOT. So the VMOT is going to go on the power layer, and my power layer, my positive power layer is the in2 layer, because my ground plane is on in1. So I could use in2, and I could use I can't use the front layer because I have the these connections there. It's actually, let's see, it's actually pretty much only the back layer that lends itself well for this. So let's see. So on the in, should I maybe do something with this? Because this connection just seems to be absolutely not good. This via is, oh. Oh, right. Okay. I'm going to just fill this up. So I'll create a corner and then another corner and just do like this. And go all the way down there because that will give a little bit more area. I'm a bit worried about this connection because this connects. This is the connection that goes between the transistors. So there's going to be a lot of current flowing here. But on the other hand, the connection is very short, so it doesn't have much resistance, so it won't get very hot because of that. But it still seems like a little bottleneck. So is this line straight? No? Did I use 25 grid? Yeah, I think I did. So I used the 25 grid. So refill this, and I should get copper all the way there. Yeah. There's no need really for that. It's just going to be a stub. Yeah. Maybe this should use an inner layer just for having a connection that goes around here. Let's see, so we have on the top layer, it looks like this. There are connections going there, so we can't use the top layer. On the other hand, we could use the top layer for this ground here. Right, here's another thing I want to change. On this pin needs to connect using a solid connection to the ground. So I'm going to edit this whole footprint. This is my custom footprint for the transistor. And I'll change the connection of this pin to use solid connection to any copper fills. And the same thing here. This is no longer a generic power pack. So refill, and no, okay. It seems I probably need to change the other pad as well. Or actually, let's see. Yeah, that's probably a good idea. So both this one and the one that is on the back as well. So solid, solid, and the one that is on the back. So back there, also solid. This is quite useful, being able to just set individual settings on each pad. Very useful. Like that. Let's see how this works. Refill, and there we go. Much better. So this is used for ground, and this layer as well. Maybe I could use actually the ground layer, because I got a bunch of wires there anyway. This is pretty much like a hole in the ground plane anyway. This I will remove. This is not necessary. Or actually, what I'll do is just use a slightly thinner track. This is totally fine as long as the track is a bit thinner. Let's see. So these layers actually connect to multiple, there are multiple layers connected to this vias, so they're always connected anyway, but I just add an extra trace here because this is a high current path, so the vias can actually get hot, but I don't think they will, because there's so much copper that leads the heat away from them. So this is not really necessary. This is just, yeah, just sort of kind of a common sense thing, I guess. And it doesn't affect the ground plane in this case, because there is a hole in the ground plane anyway. But what if I were to use the ground plane to actually connect these together? I shouldn't have that wire there, because this wire is actually in the way. It makes the thickness of the copper, or the width of the copper here, much thinner than it could be. This would be, let's change that. That's a bit better. Refill. And a little bit of a hole, or actually no, like, I will not do that because of the intersection of the fills. So if I'm gonna place a fill here, I'll have to cut a hole in the ground plane as well, and that'll just be too much work. So I'll leave the ground plane and just keep it as contiguous as possible. But maybe I could use this layer. Right. Create corner, create corner. So that's a bit better. And also, I think the clearance is too large there. Make it 35. I think that's the clearance that applies to eyes as well. Yeah. Okay. Cool. And the back is the back can be used for the ground connection. Hopefully this is low impedance enough to carry the high currents. When I have multiple layers, so I have this, and then I have this on the front layer. And I could actually make this a bit bigger here. So let's see. So the front layer. Let's see. I have to hide the footprints, otherwise it's just impossible to work with. So I take this zone, and we can hide the ground plane, so I can see the other zone there. And then I'll just create a corner, and create a corner. And do the same thing on the top layer, but without going out here. So just this part. Yeah, and I don't need to go out here either because that's already connected. Make this 35 as well. Like that. So now it's a bit thicker. That's good. Yeah. So next is this one. The default is 508, so it's a bit too much. That's better. Okay, is there any? Yeah, I think this one also has the wrong setting. Yeah, 35. All right, that's better. Footprints front, and all of this is connected. Nice. And then this one as well. So actually, I have to see the footprints. And this layer will go all the way in. And also change from the default to 35. All right. Come on. So, next, I think, I have to hide those as well. Then next I'll just update the copper fill here to also be extending downwards. This would be the back side. Create corner. All right. I think that I'll just continue doing this, and I'll update any other copper fills that I find that have the wrong settings, and then just move on to the second one. So I could actually copy all of the fills from here to the second driver, and just I don't have to redo the work here, but I'll still have to assign them because KiCad doesn't automatically copy. Alice, sluta. Bra. Because KiCad doesn't automatically copy the net names. Maybe I should spray some kind of anti-static or something on the floor. Oh shit. I just tried to pet my dog and I got the zap again. Okay. Let's see. What about this area? Right. Okay. Right. This is something I'm gonna finish off as well. I want to route this VMOT underneath, so that the VMOT comes out here and just goes through bias to the VMOT lead that goes all the way across the board here on the bottom layer. So I need to update these frames to actually allow on the back layer so that there is an opening where I can lead the VMOT down here. What is this? Oh, this is the NTC resistor. Okay. Right. Alright, that's it for this video. Thanks for watching.